All right, boys and girls, we are working on lesson 14 out of module 4. And our objective today is to look at triangles again and see if we can figure out what their angles are. So that is our objective today. And also to look at their angles compared to their sides. So let's do a quick review. This particular triangle has a side or a line segment that's about 4 inches. And we have one up here that's 5.5, and one over here that's 5.5. If we know that we have two equal sides, that makes it an isosceles triangle. So it's isosceles. But it's not only isosceles, it also would either be a right, obtuse, or scalene. So if you look at each of these angles, a right, obtuse, or acute, not scalene. If you look at each of those angles, they are all acute. So it is an acute isosceles triangle. It has 3 names. Isosceles acute triangle, acute isosceles triangle. Let's go ahead and look at this one. What do you see right away? Well, gosh, I hope you see that right angle. I see that. So we already know it's a right triangle. Not as in a wrong triangle. It's a right triangle. But let's also look at our sides. We've got a 5.5 inch side. We've got a 5 3/4 inch side. Let me just double check this one again. Yeah, that's 5.5. And this side is well beyond 6. So, none of my sides are equal. What kind of a triangle is that? It is a scalene triangle. So again, 3 names, just like your name. You have your first, middle, and last. This has right scalene, and then its last name is always triangle. So a right triangle, because this is a 90 degree. You can use your protractor, obviously, to check. This is my protractor from home, but I can see that it is a 90 degree triangle. Alrighty, that's a good review. Let's look at this one. What do you notice here? Yeah, of course, it has another right angle. So that automatically makes it a right triangle. Now we have to figure out our sides. So we've got 5 3/4 inches. We've got 4 inches. And we've got over 6 inches. So none of my sides are equal, which makes it scalene. Alright, so as you can see, it's a right scalene triangle. So it's a scalene. So those are its 3 names. Let's go ahead and look at this next one. If you look at this triangle, can you see that this angle right here is definitely a obtuse angle? Well, the best way to figure that out truly is to measure it. So here, my friends, is my protractor. I'm going to line it up with one of my long sides. Make sure that my 180 is right here. And it looks like we're at about 130 degrees. Obviously, that is obtuse. So that makes it an obtuse triangle. See if you can figure out what else it is. Pause this to wait. So if you said that the sides do not look equal, you are correct. Because if I look here, I have 5 inches. This is well beyond 6 inches. And this side is only 3.5. Therefore, it is an obtuse scalene triangle. Now, if we look at this triangle and we look at our sides, what do they look like to you? Do they look equal? Well, let's check. This one is 5 inches. This one is 5 inches. And this one is 5 inches. Therefore, it is equilateral. And if you look at your angles, these angles, if we measure them, if we measure our angles, we can see that this is about 60 degrees. If we measure this one, same story. vertex to vertex, 60 degrees. And our last one, vertex to vertex, 60 degrees. So it is not only equilateral, it is also acute. So it is an acute equilateral triangle. If you look at this last triangle, you may say to yourself that two of the sides look equal. And the only way to know that is to go ahead and measure. So if I measure, this one is well beyond 6 inches. This side is 4.5 inches. And this side is 4.5 inches. So I have two equal sides, which makes it an isosceles triangle. But then we need to look at the angles, sides and angles. This is an acute angle. You can see it. This is an acute angle. You can see that too. Then this one, I think we should probably measure it because it looks right to me. But let's check it. Oh no, it's a little bigger than a right. So it's about 110 degrees. Therefore, this is an obtuse angle, which makes this an obtuse triangle. The sides, we had two equal sides. We had one obtuse angle. It's an obtuse triangle. So here's our problem set. This one is asking us to draw triangles that fit the following classifications. We're going to use a ruler and a protractor and label the side lengths and angles. So a right and isosceles triangle. So here's my right and isosceles triangle. I have two equal sides, but one of them, both sides need to be equal, but I have to have a right triangle. So here's what I'm going to do first. I'm going to draw a straight line down, 2.5 inches, and a straight line over 2.5 inches. So that way I know that I have covered my right triangle and my isosceles. Let me just double check this because this looks weird to me. Oh, it's because I did 1.5. No wonder it looks strange.